For the past several years, the whole story around artificial intelligence has been about exponential growth and, let's be honest, a lot of speculative breakthroughs. But that era, it's coming to a close. We are now entering a new, much more critical phase, the great execution. Today, we're going to make the strategic case for why 2026 is the year it all begins, the true start of AI's industrial revolution.
So, the conversation is no longer about what AI might be able to do someday, it's about what it is doing, right now, in the real world, at scale, and under pressure. The whole mandate has shifted from speculative innovation to disciplined, almost clinical execution. This is all about integration, reliability, and delivering a real, measurable economic impact.
Okay, so here's how we're going to break this down. First, we'll talk about what it means for the great execution to arrive. Then, we'll introduce a really critical framework I call the triad of intelligence. From there, we'll look at how AI becomes an industrial utility, what new strategic battlegrounds that creates, how to separate the signal from the noise, and finally, why integrated systems will always beat standalone models.
So, what do we actually mean by the great execution? Well, think of it as the point where our focus shifts away from the novelty of a single, shiny new language model and moves toward the complex, often unglamorous work of building these integrated, end-to-end industrial systems that actually work. Success isn't measured by a model's score on some academic benchmark anymore. It's measured by deployed operational systems that solve real-world problems. So think less about research papers and more about diagnostic accuracy in a hospital, or grid optimization for an energy company, or efficiency gains in a supply chain. The real value is now created through application, not just invention. Now, this industrial shift isn't just happening in a vacuum. It's being driven by the simultaneous maturation of three distinct but deeply interconnected pillars of technology. I call this the triad of intelligence, and its convergence is really the main catalyst for this 2026 inflection point. The first pillar is embodied intelligence. For the first time, we're seeing general-purpose humanoid robots become commercially viable. And look, these are not your old-school single-task assembly line machines. These are adaptable platforms designed to operate in our world, finally moving from the research lab into the physical economy. The second pillar is architectural dominance. Let's be clear, none of this is possible without the raw compute power to drive it. Next-generation hardware and entirely new chip architectures are finally providing the performance, and just as importantly, the energy efficiency that we need for scaled, real-world deployment. And the third pillar is agentic sovereignty. This is the critical evolution on the software side. We are moving beyond these passive AI tools that just respond to a prompt. We're moving into an era of proactive, autonomous AI agents that can execute complex, multi-step tasks to achieve a specific goal. Okay, let's look at the actual evidence for that first pillar, embodied intelligence. This isn't some distant future concept. This stuff is on the committed product roadmap. The age of the prototype is over. The age of the production unit is here. What's really interesting here is just how specific this is. We're talking about Boston Dynamics Electric Atlas deploying to partners like Hyundai and Google. 1X's Neo is scheduled for its first customer deliveries, and both Tesla's Optimus and Figure AI's Figure 3 are laser-focused on real-world deployment in industrial settings. This is that crucial transition from prototype to product, and it's happening in 2026. Now let's turn to the hardware that powers all of this. The pace of innovation and architecture isn't slowing down at all. In fact, it's accelerating into a new phase of manufacturing and design, one that's driven by some really fundamental breakthroughs in process technology. This timeline really illustrates these generational leaps. 2024 was defined by NVIDIA's Hopper. 2025 brings their Blackwell architecture and AMD's very competitive MI350. But 2026, that's the true inflection point. That's when Intel's long-awaited 18A process node finally comes online, representing a fundamental manufacturing breakthrough. This new foundation for compute literally changes the economics of deploying AI. So, when you combine this advanced hardware with mature software, AI goes through this fundamental transformation. It stops being just another software tool, and it becomes a foundational utility, something as essential to modern industry as electricity or the internet. And look, this isn't just speculation. Industry leaders like AMD CEO Dr. Lisa Su have made it perfectly clear that the investment in this foundational layer, it's not a short-term trend. This is a sustained, multi-decade build-out of core global infrastructure. This new utility is being woven right into the fabric of our most critical sectors.
In healthcare and the life sciences, it's massively accelerating drug discovery and diagnostics, moving from the lab bench directly to the patient's bedside.
On the factory floor, it's powering the next generation of robotics and advanced manufacturing. We're seeing it in predictive maintenance, in quality control, and in the creation of these incredibly resilient supply chains.
And for us as individuals, it's enabling powerful new assistive technologies. This enhances accessibility, productivity, and ultimately our quality of life by making the digital world more navigable for absolutely everyone. This slide really shows the real-world impact. By 2026, the AI biotech sector is entering what I call its clinical era. We're not talking about models anymore. We're talking about actual molecules. Companies like Iambic and Generate will have AI-designed drugs in human trials. Molecules like APT1 are already showing they can boost chemotherapy response. This is the industrialization of biology, happening right now.
And to understand the sheer scale of this shift, just look at this one sector. The AI and healthcare market alone is projected to hit nearly $187 billion by 2030. That's the economic reality of an industrial utility.
So as AI becomes this core piece of infrastructure, the very nature of competition changes. The fight is no longer just about who has the best algorithm. It becomes a strategic battle over physical resources, political frameworks, and, of course, hardware supremacy.
The key strategic arenas are now crystal clear. You've got regulatory conflict creating this complex global maze. You've got energy availability becoming a primary physical bottleneck. Data center location is now dictated by grid capacity. This, in turn, is driving the race for sovereign AI as nations want to control their own destiny. But underpinning all of it is that fundamental battle for hardware supremacy. This table gives you a fantastic snapshot of that competition heading into 2025. You can see the different strategic bets being made. AMD's MI350 is an absolute monster for memory-intensive training. NVIDIA's B200, on the other hand, is all about energy efficiency and their market-leading inference performance. This isn't just a spec war. It's a clash of industrial strategies for powering the new economy.
Okay, so in a landscape this competitive, this noisy, how do leaders distinguish meaningful progress from just marketing hype? The key is to focus on structural shifts. And the single most important structural shift happening right now is the rise of autonomous agents.
The crucial skill now is to filter the noise from the signal. Noise is chasing those incremental leaderboard scores or releasing a slightly better version of the same model. The signal, the real breakthrough, is something that structurally changes the economics of compute, or dramatically improves energy efficiency, or enables entirely new physical applications that were just impossible before.
And the loudest, clearest signal for 2026 is the maturity of AI agents. This is the big shift, from a passive model that just answers a question to an autonomous system that actually completes a complex task from start to finish.
Here's a tangible example of what an agentic workflow looks like in healthcare. It's not one step, it's a whole chain of reasoning. The agent ingests unstructured patient data. It formulates a diagnostic hypothesis. It validates that hypothesis against external medical literature, and then it generates a report for a human expert to review. This is the leap from answering prompts to actually solving problems.
This brings us to our final and, I think, most important point. It's the core analogy for understanding this entire shift. The future belongs to integrated systems, not standalone models. This is the central lesson from every single industrial revolution that has come before.
For the last few years, the entire industry has been focused on building a better engine, the large language model. It's incredibly powerful, sure, but on its own, it's a static component. It has a ton of potential, but zero utility.
So next, we built the automobile around that engine. This is the specialized hardware, the GPUs from NVIDIA, AMD, and Intel. This is what gives the model power, efficiency, and the ability to operate in the real world. Now it can actually move.
But now, in 2026, we are building the highway system. This is the software infrastructure, the agentic networks, the data pipelines, and the energy grids that allow all of these automobiles to connect and operate at a national scale. This is what creates the network effect.
Because the ultimate goal isn't just a fast car or a smooth highway. The goal is the national grid, a fully integrated, completely reliable, and basically invisible industrial system that powers the entire economy. That is the great execution.
So, to summarize the strategy for 2026 and beyond, it really comes down to three core principles.
Clinical execution beats chasing scale for its own sake. Deep integration into existing workflows beats the novelty of a cool new demo. And robust, end-to-end systems will always beat a standalone model.
And this is the fundamental shift in thinking we all need to make. The technology is here, the infrastructure is being built. The question for every leader is no longer about potential, it is about execution. The strategic imperative has arrived. So, what will you build with it? Thank you for watching.